The pH scale is a logarithmic scale from 0 to 14 that describes the free hydrogen ion concentration in a solution. You should also note that sometimes the free hydrogen ion concentration in a solution is also known as the hydronium ion concentration in a solution and is sometimes abbreviated as H3O plus rather than H plus. The scale is based on water's natural dissociation constant, which can be seen at the below formula. Water naturally breaks into H plus and OH minus ions. As you can see, H2O breaks into H plus and OH minus ions. This is hydrogen ions, or sometimes called hydronium ions, plus hydroxide ions. These ions both occur at 10 to the negative 7th each. So when you add them up, you get 10 to the negative 14th. And when you use the pH formula, you get 14, which gives you the logarithmic scale 0 to 14. A review of water shows us that water is a polar molecule. Recall from the previous lessons that water has two hydrogen atoms and one oxygen atom, giving it 10 electrons. Since there's wild differences in electronegativity between hydrogen and oxygen, the electrons tend to spend most of their time surrounding the oxygen atom. This causes a positive charge on the hydrogen side and a negative charge on the oxygen side. This is what it means to be polar. We can illustrate the pH scale using this graphic. We start off with water, which looks kind of like Mickey Mouse. And when it breaks apart, you get a hydrogen ion, which is also known as a proton because it's lacking an electron, and a hydroxide ion. Again, a hydrogen ion can sometimes be known as H3O plus since it tends to associate with a water molecule and can be called a hydronium ion. If a substance produces many H plus molecules and few OH minus molecules, we call it an acid. On the pH scale, this produces a number of 0 to 7. A higher concentration of hydrogen ions in a solution is called an acid. There are two theories that we will talk about in the future that define an acid, but for right now, we're just going to say that if it's 0 to 7 on the pH scale and produces a hydrogen ion, it's an acid. On the flip side of that, if it produces a 7 to 14 on the pH scale and has hydroxide ions, more hydroxide ions than hydrogen ions, it's a base. So this would be an example of an acidic solution. Notice that you have a high number of hydrogen ions and a low number of hydroxide ions. When this situation happens, you have a high number of hydrogen ions and a low number of hydroxide ions. This would be somewhere from 0 to 7 on the pH scale. A basic solution would be just the opposite of this. You have a high number of hydroxide ions and a low number of hydrogen ions. Let's do a few practice problems to make sense of this. Practice problem number 1. Here we have HCl dissociating into H plus and Cl minus. What do you think this is? Is this an acid or a base? And where would it fall on the pH scale? Let's find out. Well, if we look at the right side of the equation, we'll note that we have an H plus and a Cl minus. We're not so focused on the Cl minus, but we have an H plus. This H plus tells us that we're having a high number of hydrogen ions, or sometimes called hydronium ions, inside of our solution. If you're having trouble reading this, basically what this means is the HCl breaks up into water, produces H plus and Cl minus. The H plus is going to produce either an acid or a base, and we'll find out what that is in just a moment. Now recall back to when we were talking about what is a solute and what is a solvent. So here we have some HCl and here we have some water, and this is actually what it looks like. So which one is the solute and which one is the solvent? If we put HCl in water, which is what that reaction was, and you have to do this to get the breakup to occur, which one is the solute and which one is the solvent? It turns out that HCl is the solute, the powder on the left, and water is the solvent, the water on the right. And this is what happens. Cl separates from H, and you get H plus ions. Now recall that we had this equation, HCl with H plus to Cl minus. So is this an acid or a base? And it is an acid, and the reason is because we have H plus ions being put into solutions. So when you see H plus ions, you know it's an acid. Where could this fall on the pH scale? Anywhere from 0 to 7. Next practice problem. We have NaOH going to Na plus and OH minus. Now remember our definition of a base. So here's our example. We have NaOH on the left and water on the right. Which is our solute and which is our solvent? That's right, NaOH is our solute and water is our solvent. Here's an example of how that might play out. Notice that now we have an NaOH, or a hydroxide ion, and a sodium ion left over. So if the solution is producing, or if this is producing an hydroxide ions in solution, we instantly know that this must be what type of solution, acidic or basic? What do you think? That's right, it must be basic because it's producing OH minus. Where could this fall on the pH scale? Basic solutions fall between above 7 all the way to 14. So here's another practice problem. We have KOH plus K plus going to K plus and OH minus. Think about the last one we just did. Is this an acidic or a basic solution? What is it producing? Look at that OH minus. Is that an acid or a base? Well, there we have it. So there's our KOH, and there's our water. Which is the solute and which is the solvent? Well, since it has KOH, or KOH goes to OH minus, this is a base. And where could this fall on the pH scale? Anywhere from above 7 to 14. I think this one should be pretty self-explanatory. Again, this is going to be a base. The solute is going to be the white powder, and the solvent is going to be the water. And since it has OH minus, we know that, or hydroxide, we know that we're dealing with a basic solution. pH, this has to be above 7 to 14. Here's another problem. We have HClO4, and this is going to H plus and ClO4 minus. What is this producing? It's producing H plus ions. Is that an acid or a base? That's what it looks like. Well, the solute is going to be the HClO4, and when you add it to the water, well, that's the solvent. Together, that's the solution. And you guessed it, it's producing H plus ions. Therefore, it's an acid. On the pH scale, this would produce be somewhere between 0 and below 7. Let's do one more. Here we have H2SO4, and it produces 2H plus and SO4 minus. Is this an acidic or a basic solution? You guessed it, it's acidic. And the reason is because it produces H plus ions in solution. Last one. What is this producing? H plus ions or OH minus ions? That's right, it's producing hydroxide ions. Therefore, it's basic. Where could this fall on the pH scale? That's right, above 7, all the way to 14. Hopefully this helped you figure out how to identify between an acid and a base and where it could fall on the pH scale. If you need more help, feel free to ask your instructor for help. I hope this video helped you. Good luck in your endeavors.